Ignition sequence start.
Good morning. Here's the view inside the International Space Station Flight Control Room, where there is always a team of flight controllers on duty to keep tabs on the station systems and assist the Expedition 65 crew members as they work through the tasks on their agenda each day. This week, Space Station Commander Aki Hoshide and his American, Russian, and French crewmates were busy supporting science experiments in the station's lab modules, while also keeping up with all the routine maintenance that it takes to keep their orbiting outposts flying in good shape.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, a new space plant growth experiment was kicked off, water bears were brought out of hibernation, and we're getting closer to the upcoming launch of the largest module to the space station yet. On Monday, NASA astronaut Shane Kimbrough began work on the Plant Habitat 4 experiment, which involves growing peppers in space for the first time ever. Peppers are more difficult to cultivate than many previous space crops because they take longer to germinate, grow, and develop fruit. This investigation is part of ongoing efforts to establish ways to grow food crops on long-duration space missions. Plant Habitat 4 could help advance the technology on Earth for growing plants in controlled indoor environments and use significantly less water. And on Tuesday, Japan Aerospace Exploration Agency astronaut Aki Hoshide began scientific work on water bears. The Cell Science 4 experiment involves tardigrades, also known as water bears, due to their appearance under a microscope and common habitat in water. Tardigrades are tiny creatures that tolerate extreme environments. Cell Science 4 characterizes the molecular biology of short-term and multi-generational survival of water bears, identifying the genes involved in adaptation and survival in high-stress environments. The results could advance understanding of the stress factors affecting humans in space and support the development of effective countermeasures. The International Space Station is about to get a little bigger thanks to a new Russian module launching soon. The Russian multi-purpose logistic module named Nauka is currently scheduled to launch on Wednesday, July 21st on a Proton rocket from the Baikonur Cosmodrome in Kazakhstan. MLM will dock to the nadir port of the Russian segment of the station and will be the largest module ever launched to the space station. Both operations will be shown live on NASA TV, so be sure to tune in. Also launching with MLM is the European robotic arm, which will serve as the main manipulator on the Russian side of the space station. The arm has the ability to perform many tasks automatically or semi-automatically, can be directed both inside and outside the station, and can be controlled in real time or pre-programmed. The arm can help install, deploy, and replace elements in space, saving the crew time and effort on station maintenance. And that's Space to Ground for this week. Thanks for watching. Do you have a question for us? #AskNASA. We'll see you next week.
The weightless environment of low Earth orbit is essential to carrying out all of the physics and biology research supported on the International Space Station. For example, there's an experiment involving a device as small as a thumb drive, and it contains human cells in a 3D matrix. Scientists are using these devices to help learn how human cells respond to stresses, drugs, and genetic changes. The devices are known as tissue chips. The International Space Station is well known as an orbiting laboratory, but its mission also includes preparing us for future exploration, improving life down here on Earth, and encouraging the commercialization of space. In that area, one of its great success stories is a product called CubeSats.
Think of the International Space Station, and most likely you imagine an orbiting laboratory where scientists observe how plants, materials, and humans react to microgravity conditions. But during the past decade, the station has also served a very different role, that of being a business incubator. And this is one of its star products, the CubeSat. The CubeSat is one of many types of satellites now found in space. It is one of the smallest. One unit is a compact 10 by 10 by 10 centimeter cube and is commonly referred to as 1U. And it can be deployed for a fraction of what its larger cousins cost. Early small satellites launched from the station were literally thrown into space by Russian cosmonauts. In 2012, crew members began utilizing the airlock in the Japanese Kibo module to deploy up to 6U of CubeSats per airlock cycle. And not long after, the American company NanoRacks built and began operating an even more robust deployer on the station, capable of launching up to 48U per cycle. That changed everything. Mike Reed is the manager of Space Station Business and Economic Development at Johnson Space Center. He notes how one of NanoRacks' first customers, Planet, leveraged the new launch capabilities aboard the space station. Planet wanted to take high-resolution photos of Earth. While you can take pictures from the space station, your coverage is limited by the station's orbit. With multiple CubeSats, however, you can position them to cover almost any point on Earth. In a relatively short time, Planet deployed several generations of CubeSats from the space station, proving the viability of their technology approach and their business model. With these successes, Planet quickly expanded to an operational fleet of over 150 satellites deployed using commercial launch providers. This fleet gives them the ability to image the entire Earth's landmass every day. Planet's imagery is now in high demand by companies and governments who use this big data in the fields of agriculture, forestry and land use, mapping, and disaster response. Within a decade, the company has grown from a true startup to employing nearly 500 people. Multiple companies are now building small launch vehicles specifically to deploy CubeSats and other small satellites into low Earth orbit, for use in a variety of ways for companies as well as students and nonprofit organizations. CubeSats are being used to provide internet services to even the most remote regions of the planet. They're helping build better weather and climate models to improve weather forecasting. They're enabling text messaging for your phone around the globe, even without a cell signal. CubeSats are also leaving the planet. The first and second interplanetary CubeSats accompanied NASA's InSight lander on its recent mission to Mars, relaying data about the spacecraft as it entered the planet's atmosphere. Some CubeSat missions will serve as pathfinders to help map the way for the Artemis missions to the Moon. And 13 CubeSats will launch on the first mission, Artemis 1. Reed concludes with this observation. Today, more and more, a single large and expensive satellite is being replaced by one of the newest members of the satellite portfolio, a flock of small, less expensive, yet very powerful CubeSats. Affordable access to space has broadened the station's capabilities in a way that, frankly, was never envisioned. However, that access has enabled CubeSats to become a sustained commercial success, contributing significantly to the growing space marketplace. For more science and research from the International Space Station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
Many of the astronauts who have lived and worked aboard the International Space Station say that looking out the windows down at planet Earth is one of the very best parts of the whole experience. In this demonstrations episode, astronaut Randy Bresnik discusses the station's role as an Earth monitoring and diagnosis station, while showing some of the amazing images he and his colleagues have captured on their journeys off the planet.
Hello, I'm astronaut Randy Bresnik. Want to know one of the best parts about being an astronaut up in space? Our view of the Earth from the International Space Station is absolutely spectacular. And viewing the Earth from space is a big part of our job. In addition to many other important functions, the International Space Station serves as a global monitoring and diagnosis station where we can conduct observations across the globe, aimed at understanding and resolving environmental issues we face on our home planet. Let's have a look. The space station offers a unique vantage point for observing the Earth's ecosystems with hands-on and automated cameras and image capture equipment. These tools enable astronauts to both observe and explain what they're witnessing in real time. The image capture equipment on the space station also provides input to personnel back on Earth, working to program the station's automated Earth sensing systems, providing flexibility and an advantage over sensors on unmanned spacecraft and satellites. Scientists and researchers find this especially useful when unexpected natural events such as volcanic eruptions, earthquakes, hurricanes, fires, and other natural disasters like floods occur. Through existing international and interagency partnerships fundamental to the International Space Station, data sharing that can benefit people around the world is facilitated, promoting international collaboration on a range of Earth observation activities. A wide variety of Earth observation equipment can be attached to the space station's exterior, like I did on one of my spacewalks. Several instruments have already been installed, and researchers from around the globe are proposing additional payloads to install. In continuing to use a combination of crew-operated and automated Earth observation payloads, the space station collects crucial data on the global climate, environmental change, and potential hazards to the health of humanity and our home planet. The Window Observational Research Facility, or as we call it, the WRF, provides a highly stable internal mounting platform to hold cameras and sensors. With the WRF, the high-quality optics of the nadir, or the bottom viewing window of the space station, allows us to look straight down onto Earth. Do you want to participate in some of our Earth observation missions? Come join us. Check out the Sally Ride EarthCam website. Go to earthcam.org and follow the instructions to sign up. And have a look at some of the spectacular Earth views from space and see what you can identify. You can also try the activity in the link we provided in the description of this video. Thanks for joining me. See you all next time.
The arrival of the Soyuz to the International Space Station last April was the start of NASA astronaut Mark Vande Hei's second long-duration spaceflight, the first coming more than 3.5 years ago when he was a member of the Expedition 53 crew. The U.S. Army retired colonel says he's eager for another shot at all the things he knows are coming his way.
So, arriving at the space station, something I'll never forget is looking over my left shoulder out the window in the Soyuz, where it was either a view of the Earth or blackness of space. And then all of a sudden I could see a solar array. Getting chills even thinking about it right now. It was this beautiful gold, massive. I mean, you don't ever train and see a solar array at full scale here. And so there it was, and the Russian commander sitting to my right. I had to really pay close attention, and I was supposed to be too. But as soon as I saw those solar rays, I broke the silence and said, "Wow!" And he was like, yeah, I was definitely a rookie. I was excited. The freedom of motion inside of the space station is huge. And then working was busy. It was definitely very busy. I got up there when a SpaceX Dragon spacecraft was docked, just because there's a lot of science that requires return and things have to be done in a very specific timeline. It was very fast-paced immediately. And the space station is very unique because on the space station, orbit is really a continuous freefall. And because of that, you can have some very unstable structures that might not be able to stay together if you're on the ground. They could stay together on the space station. Flames behave differently because combustion on the ground requires drawing in all these rich gases into the flame because the hot combustion gases go up and away. But there's no up and away on the space station. All directions are equal as far as that's concerned. So that behaves differently. There's all kinds of different phenomena that we can experiment with. That's why it's a wonderful laboratory. Many, many different experiments. Some of those experiments actually have to do with us as the test subjects because we're trying to understand how to have people safely travel for longer and longer distances too. That's just a sub-part of all the science we're doing on the space station. Some people have talked about at some point in the expedition feeling like it's time to go home, but for me there was always another spacewalk or another vehicle capture that was coming up, so it always felt like suddenly I was going home and it surprised me. I'm Mark Vandehei, and I'm a NASA astronaut.
Can you imagine what the Earth looks like from 250 miles off the planet? Well, now you don't have to. International Space Station astronauts have worn small, high-definition video cameras during 4 recent spacewalks to give you that exact view. And it does not disappoint. Have a look for yourself with this compilation from spacewalks carried out between July of 2020 and March of this year. Many NASA astronauts who have had the chance to look down at Earth for an extended period of time return to the planet with a new appreciation for it. It's also been true for those who took a trip to space on a space shuttle mission that only lasted a week or so. Take it from former astronaut Bill MacArthur. He's made both kinds of trips.
When you first get to orbit, of course, main engine cuts off, and it's really funny. It's really not funny, but it's fun to watch everyone. I think everyone takes whatever writing utensil he or she has and releases it, because it's I want to see something float. Yeah, I know I feel floaty, but now I want to see something float. And then as quickly as you can, particularly a first-time flyer, it's to the window. The first thing you're overwhelmed with is how darn beautiful it is. It's darn exciting. And so immediately you're trying to identify geographical features, identify places. You look and you see things like a massive thunderstorm, a supercumulonimbus cloud coming up, and it really does come up at you. It is that tangible nature of what you're seeing that really does take your breath away. I worried my family when I was sending them notes because I started talking about the black velvet of deep space. You look in the sky here on the Earth and, it's like Milky Way or those thin clouds up there. What am I looking at? But everything is really, really vivid. And I think that's another part of the visual aspect, whether you're looking out or looking down. It's part of the same thing of taking a picture of someone. Nothing captures vivid colors and texture and subtlety like the human eye does. And when you're in space, it's the same thing. And I think that's in part why it's such a powerful personal experience. And as much as we love the pictures that we bring back, it's not the same as seeing it yourself. There's a certain serenity that comes. It's not just from what you've seen. It's from realizing a tremendous goal that you had. And that's something I felt right after I got on orbit the first time is, heaven forbid, I could perish now, or I can never fly again, but nothing can take this experience away. I own this experience. It is mine forever.
If you want another look at any of the stories you saw today, you can find them on YouTube and Facebook, along with lots of other great features on a wide variety of NASA topics, so be sure to look around. And if you're looking for good conversation about human spaceflight, check out Houston We Have a Podcast. It's our weekly show talking to folks involved in all areas of space exploration. Today, Gary Jordan explores another aspect of the NASA intern community, hosting a discussion about women involved in STEM careers. Go to nasa.gov/podcasts for this week's episode, all of our previous episodes, and the full library of NASA podcasts, which you can also find on Apple Podcasts, Google Podcasts, and SoundCloud.